Hello Internet! In this video we are going to be looking at the Spring framework and specifically Spring Boot. We're going to be setting up a basic MVC web service that's going to be able to take a HTTP request and respond with some JSON. So I'm going to be using the basic, more or less just walking through the guidelines for Spring's Gradle setup. And that's sort of designed as, I don't know, we're both going to set it up. So I've got some experience with this, and I'll kind of try to explain the steps in a little more depth than they go here. I have their website pulled up, and we'll just kind of try to keep them side by side, and hopefully it's a little bit more explanatory. I don't know entirely how this is going to go. You'll have to let me know how this format works, because I haven't really done much with it. So we have a totally new project that we're going to be setting up. I'm going to be making it in Java using Gradle, and I'm going to be using IntelliJ. So this is IntelliJ 2017, and we are going to be building it in Java 1.8, which is the newest version of Java, I think. So let's create a new project with Java using Gradle. Next, give it an artifact ID, Spring Test. Sure. We'll version it as the 1.0 snapshot, and that should be good. So now we need to set up how we're going to actually use Gradle. I'm going to just use the default Gradle wrapper, which is actually going to use what IntelliJ has. You can actually specify the local Gradle distribution if you want to use a specific one or whatever. But this should be fine for what we're using. And then you don't need to set up this Gradle home. So we'll import that, set up our project name, throw it there. That should be good. We'll open it in the same window, and it should just build us a really basic project. So we've got this .idea folder is IntelliJ's solution. It's IntelliJ's project file. It's where all of the information about the project is stored. And then we get a settings.gradle, which just has the name, and then the build.gradle, which is where we're going to be doing a lot of our work. So Gradle is it's a build system. So what it allows you to do is actually pull in some of your resources and actually specify dependencies. It can do a lot of really great stuff, and it's super easy to use and fairly well written. So it's implemented in Groovy, which is based off of the same JDK as Java. So if we scroll down here, this is just giving some basic examples of what they're trying to build. They're doing just a hello world that can respond to the user. We've done all of this. They've got the build Gradle here. So what they want to do is create a source main Java hello folder. So hello is going to be the package name here. And then this is just the default layout for everything in the project. So if I go here, create a new module, that's not right. Don't do that. Let's create a new directory, call it source. This part is a little bit painful. I think there might be a better way to do this. If you go into like PowerShell or your shell on Linux, like bash or something, you can actually just make all of these directories at once. They actually give you the command here, but this works too. And then let's create a package here. Let's call it com world of 0 dot hello spring. And so this is similar to namespaces in C#. It's just a package. So that's just our basic folder structure. We're good there. Then they have this build.gradle that more or less we just need to copy. We can keep like the version and stuff, which they don't have here. And that version is going to actually allow us to version each of the binaries that we generate. So you can actually, if you have it stored, like if you're storing your binaries, you can actually reference specific versions. And this is how you would do that. So let's bring in these build script things. Stick that there. We're going to need those four. So the plugins just add a bunch of additional features to the Gradle. So then jar boom Source compatibility, this is saying what version it's compatible with. I don't know what target compatibility is. Should probably look that up. A lot of this stuff is kind of outside of the scope of this. It's more introducing Spring than it is all of this Gradle stuff. So some of it I'm going to skip over because I don't necessarily know enough about it to talk about. And some of it I'm just going to skip over because I don't want to talk about it. So the main thing that you need to do is actually make sure you include your dependencies. So we need to include the Spring Boot starter web app, which is actually a package of packages. So this actually contains a number of additional Spring packages. I think there's like 8 or so in there. And that's what you need to actually get started. And then the other one is actually for test. You'll notice there's a compile and a test compile. So the difference there is compile is compiled actually when you're actually running your project. Test compile is used for tests. So it's not needed for the final binary. Then they talk about a bunch of other stuff. And we don't need to worry about any of that, I don't think. I'm trying to go relatively quick because you guys probably you can read. So there's no point in me going super long on all of this. So they're talking about the Json query. This is the sort of the formatting they're looking for. They're doing a get. And so this here is going to be the data model that is going to match this exactly. So these getters are what actually get mapped. So the get gets dropped and it actually just gets dropped in there. So I don't think if you forget to add these getters, I don't think your content gets serialized. I think I remember running into that issue, but it's been a while. So generally, this is usually the format you're going to follow because this gets you an immutable model, effectively, that you can give to anybody. So let's create that. They're just putting it there. I'm going to actually create a new, well, let's create 2. First, I'm going to create an application. So the application is going to be where you actually enter. So that'll have our main void function. Then I'm also going to add a models package. And we're going to stick this in there. So let's just call it the greeting view model. For me, some people will disagree on this, but I like to actually label these as view models, and then I have data models, which will represent data that is actually stored. So usually the view models represent things that are actually displayed. So they cross the boundary between the web app and something else. And then the data models are used internally or for like databases, which is not necessarily a clean break, but it's cleaner. So we're going to declare these as final here, which means they can't be changed. And this is actually going to throw an exception because it's not going to compile, because we cannot compile, or we can't create a class with final variables that aren't set. And since they're not being set because we haven't finished our constructor yet, that's invalid code, and the compiler won't let you do that. So we're going to finish this up, and those should go away as soon as I finish this. So let's set up our ID and our content. And let's throw in these getters here. So we get return ID. And we'll do a string, oops, and get the content. So this is just returning an ID of whatever hello message you're saying, and then the content. So there's some really interesting things. I've actually really found that Spring has a lot of nice things that I would kind of wish that C# would take on. I've done kind of a lot more work with C#, and then lately it's been a lot with Spring. There's a lot of the injection of stuff. The dependency injection is a lot nicer in Spring, mostly because it's just more explicit. What? Oh, greeting view model. There we go. But yeah, so there's a lot that you can do in Spring. I'm not going to cover all of it here because that would take hours. And I don't really have hours because I have work tomorrow. But we can definitely get into more and more of that as this goes on. This is sort of the core basics. That's why we're starting with the Getting Started guide. So the next thing they're doing is creating a controller, which is actually going to control things. It's the exact same thing as a ASP.NET MVC controller. What that does is it handles the core functionality. So it is what is actually exposing endpoints for you to hit. So what do we need for this? Let's create a controllers folder or package, and then we'll call this the greeting controller. I suppose I could have like taken this in a different way. You can do whatever you want with this. This is strictly just taking information, calculating something, and returning something. So you can take this and do whatever you want with this. I may need to refresh my Gradle dependencies because these aren't going to exist. Yeah, so if you can actually turn it on to automatically refresh your Gradle dependencies. I did not. So you have to actually open this Gradle folder or this Gradle tab and actually refresh your dependencies. It should still build, but IntelliJ is not going to know what packages you have because it hasn't found them yet. So assuming that our build.gradle is correct, IntelliJ will actually pull down all those packages we have specified there. So the Spring starter framework we added, it should pull that in, and then we should be able to actually complete this. And you'll see this filled out a little bit. So we get some validator stuff. We get more starter stuff. We get the Jackson serialization and a whole bunch of other packages. So now I should be able to, there we go, import that. And so now we've got our REST controller. Let's actually, that's interesting. So they actually have like a template string that they're using, which is just hello something. So this is just going to be plugged into a string formatter, I'm guessing. Yeah. And then the next thing is an atomic long. And so an atomic long in Java is a counter, effectively. It's a counter that is thread safe. So as you increment it, regardless of what thread you're incrementing it on, it won't get out of sync. So every increment will happen atomically. And because of that, you don't run into any race conditions or anything, which with web services it's important because you can have multiple people calling these controllers at the same time. And so theoretically, it is possible for, even though it doesn't look like there's concurrency here, there still could be. So that's something to keep in mind. Let's see here. Request mapping. So what this is doing here is exposing a greeting endpoint on our service. And so we're saying, if you call whatever our server is /greeting, we want to do this. And I'm going to return our view model. It will automatically serialize it. Yeah, it will automatically serialize it into JSON or whatever else you specify. You can, if you want to send back XML for whatever reason, you can do that. And I believe there is a request. This may not be the right one, but effectively it's similar to the way that it's handled in .NET, where it's actually wrapping a REST request. I forget exactly what it is. But there is a request somewhere that I'm totally blanking on, but that's not really needed here. It will automatically do the serialization if you don't include that. But if you want to handle error codes. Like you want to say 404, that user isn't found. You would need that in order to support that. So let's add a greeting here and say we're going to add a parameter, which I can close that. So our request param is going to have the value of name with the default value of world, which means if you don't provide a name, so if you don't provide this request parameter, it just defaults to world. And if you do, then we'll take it. So let's do string name. So the request parameter is going to be, if you have ever done a request, it would be like adding on a question mark, name equals world of 0, for example. And then that way you would plug in world of 0 as your name. So that's how this is working. That's what you're mapping here. You are taking that and saying, I want to, when I call this greeting command, when I call that endpoint with this name, I want that to be used as this parameter. And so you can make that as complicated as you want. And there's other ways to, if you're doing like posts and you want it in the message body, you can do that. You can pretty much restrict it however you want. If you want to only accept JSON requests for validation or whatever, you can do that. Anyway, we just need to return a new greeting view model, I think. Should work. And we're going to increment and get. So this is going to increment our counter from 0 to 1, and then it will get it. So we're going to do that. And then our format, take our template that we had, and then plug in the name that we got from our parameter here. And that's it. That's our REST controller. We don't need to do anything else. This annotation, this @REST controller, is what actually exposes this to Spring. So Spring will actually find all of your classes with this REST controller here, and it will actually find all of them. It does that a lot. So this isn't the only instance of an annotation that goes and kind of makes magic happen. The ones I use the most are that, and then there's a named one, which isn't showing up. But you can actually name classes, which will allow them to be injected and effectively create singleton instances that you can kind of spread about however you feel like, which is a really nice pattern. I actually really like using that. Let's see here. We've got all of that. It's talking through a bunch of the stuff that I just talked about. Response body. Yeah, cool. Think we're good. Make the application executable. So this is where this application comes in. So we have an application, but we actually need it to be a Spring Boot application, which is just going to flag it as our entry point for Spring, I believe. I don't entirely know what that annotation does. May not be the best, but then we just need to do the classic Java static void main, and then just call Spring application.run with the application that we're actually starting with. So we're calling it with this class that has this Spring Boot application as its annotation. And then we just pass in the arguments from our shell, like that. Import that, and that's good. We don't need to do anything else. If we want, Spring has a really robust configuration thing, so you can actually add a bunch of configuration to how this whole thing is going to work, which if you want to flag features on or just have random configuration like server details, database passwords, things like that, Spring provides that, and it talks a little bit about that here. So there's configuration, there's all this other fun stuff. Not really going to go into that because that's kind of outside of the scope of this, but it's there. So you're welcome to go Go look at that. And actually, I think that's it. I think that's all we need to do. So I should be able to put a semicolon there and then just run this. Theoretically. We'll see how this works. So this is just going to build our application, start it. There we go. You can see the nice Spring logo there. And then it loads a whole bunch of stuff. And then when that's done, we can actually figure out where it started. Maybe. Port 8080. Cool. So if I go to localhost 8080/greeting, we'll get our response back, which is going to have our ID with hello world on it. And then if I want to give it a name, say world of 0, I've already done this, but it'll say hello world of 0 and our counter will have incremented. So this is the basics of setting up like a Spring server, and all we needed were 3 classes and a really simple-ish Gradle project, and we're good. If you want to use Maven or Ant, they also have walkthroughs on that. I'm not familiar with those tools as much, so this is where we are. But if there's anything else you guys want to know about this or anything else you want us to experiment with, let me know. I actually really like Spring. I think it works quite well. So yeah, if you ever need to make a website, there you go. We did it in 20 minutes, and most of that was me talking. So yay. I don't know what else to say. So yeah, if there's anything else you guys want to see, any feedback you have for me, let me know in the comments and I will hopefully get to it. If you want to talk about this or some of the other videos I've done, come join the Discord. There's a link again in the description. But that's it for this video. So until next time, see you, Internet.